Let me introduce you to the interesting and amazing world of circle theorems. But first, before I start talking about these circle theorems, I better define some terms. So radius, that is the line from the center of a circle to the outside. That's the radius. The circumference is the distance from start to finish when you draw a circle. It's the length of the curved line around the outside. The tangent, if I were to draw another circle here, a tangent would be any particular part of this outside circumference extended as a straight line. So if I were to choose that point there, extend it as a straight line, it would look like this. And that is called a tangent. A chord is inside a circle. It's a line from 2 points on the circumference. That's called a chord. Perpendicular means two lines that are joint at a right angle, and a right angle is 90 degrees and it's shown with a square. A bisector means, well, bi means two and sector means to cut. So bisector means to cut something into two, or really into half. And interestingly, if I took a chord, let's take a circle. Oops, that's too small. I should do a big one. Actually, it's good to draw a circle backwards because then you tend to draw them more circular. If I were to draw any random chord, let's say from here to here, and I bisected that, that means I cut it in half. That goes, if I were to draw a radius going through that point to the center of the circle, they are perpendicular. So if I have cut a chord in half and I draw a radius through that point, then it joins the chord at a right angle. That's quite an interesting fact. And finally, the word subtend means to hang from. So if I were to draw a chord and I drew an angle subtending from that, then it would be hanging from it. So this angle subtends from this chord. It hangs from it, it comes from it. So the first circle theorem is quite an interesting one, I think. If you were to draw a chord going through the center of the circle, this particular chord is known as the diameter. And if I were to subtend an angle from this chord, from the diameter, it's always going to be 90 degrees. And that could be proven in this way. If I were to cut that triangle in half here from that point, we may notice that this is a radius, this is a radius, and this is a radius. They're all the same length, and here we have in fact two isosceles triangles, which means that if this angle here was x, this angle here is also x. If this angle here was y, this angle here is also y. And by adding up all of these together, you can see that, let's do it, x plus y plus x plus y must equal 180 degrees. And therefore, you may spot here that you've got two of these x plus y's, must be 180 degrees, and therefore x plus y on its own, that must be 90 degrees. And that is x plus y at the top, so that must be 90 degrees. The second circle theorem, actually no, I'm not going to go into that yet. I'm just going to go through this works example. Notice we've got a diameter, so instantly we can say that A must be 90 degrees, and also B is 90 degrees for the same reason, because they both subtend from a diameter. That means I can work out what C is because of the triangle here. So that means that these two angles here add up to 90 degrees as well. The C must be 50 degrees. And for the same reason, the D must be 30 degrees. Oops. Well, I should have written D equals. I'll do that again. There you go. Right, what about this next one? This is what I was talking about with the radius, the tangent, and perpendicular. If you were to draw a tangent and connect it to any radius, well, actually there's only going to be one radius that touches the tangent, they meet at 90 degrees. So that means that you could say that the radius and the tangent are perpendicular when they meet. Now, how does that apply? We can see from here that we've got a radius and a tangent. So that means that this angle must be 90 degrees. How does that help? Because it can tell us A straight away. Looking at the triangle OAB, the 20 and A must add up to 90 degrees. So this must be 70 degrees. How does that help us work out B and C? Also, you may spot that this is a radius and this is a radius. So that means that B and C are equal. In the triangle we have A plus B plus C must equal 180 degrees. And we already said that A was 70 degrees and B is the same as C, so I'm just going to write 2B here, is 180 degrees. And then by subtracting the 70 degrees, that's 110, leaving 2B on this side. So B must be 55 degrees, which shows or implies that C must equal 55 degrees as well. Now the final example before you can start the exercises. We have 4 different letters, A, B, C and D. We have to find A first. It must be the easiest one to find. For the same thing as I said before, this is an isosceles triangle. So A and B must be equal and they must both be 40 degrees to add up to 180 in total. And for the triangle over here, this is also isosceles. D and C must be equal. But what's this missing angle? This must be 80 degrees because it adds up to 100 degrees to make 180 degrees. Therefore, C and D must both be 50 degrees. Right, have a go.